I always say the burnouts do not disappoint. The looks do not disappoint. Everything else, pretty disappointing. It's not a good car, but it looks wild. It's like a 12-year-old drew it with a crayon, and then Chrysler just decided to make it. So like if you're already cranked up to 11, how do you go farther? Well, why don't you put a 10-inch lift on it, put some off-road shocks on it, and make it an off-road Viper?
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Matt Brown, YouTuber better known as Superfast Matt. This is one of the YouTube channels that I really enjoy watching. We talk in this episode about Matt's background, and he's had some fairly interesting experiences working the likes of Nascar, as well as Tesla in their early days, and even Apple. Despite this, he's now gone full-time as a YouTube content creator. Now, this is not an easy market to break into, and we talk about his experience and how long it took before he was able to essentially monetize his YouTube channel and generally make a living out of it. I really enjoy Matt's videos because he manages to showcase some technologies that any home enthusiast these days can apply to their own builds. I'm talking here about the likes of 3D modeling, as well as making parts with a CNC router, which, as we'll find out, is kind of a little bit like a poor man's CNC. He also showcases some of the skills required to make your own composite parts, and you might find that it's actually not as hard or as scary as you thought. He's also got some really interesting project cars that he's been building, and we dive deep into both his off-road Dodge Viper project as well as his Landspeed car. Before we jump into our chat, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place, and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes, and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, welcome to the podcast, Matt. Thanks for joining us. And like always, let's find out a little bit about your background. Specifically, how did you develop an interest in cars?
Sure. So I wasn't really interested in cars until I got my first one, and it was kind of a piece of junk. So it required a lot of fixing, and I sort of went through the process of fixing things, which led to fixing things that didn't need to be fixed, which is,
modifications.
Yeah. I just kind of grew that interest. I went to college to be an engineer and was building race cars in college, and just kind of like, I don't know, it's such a enormous, you think cars, it seems somewhat limited. It's like one thing, but there's just so many different areas of it, and there's so many different ways to dive into different parts of it and be interested. So, yeah.
So the engineering passion came before the cars, and they sort of just molded together?
No, I think the cars kind of came first. I went to school. I got a degree in engineering to be an automotive engineer, but I think I really like the hands-on stuff more. And I think I've always liked the hands-on stuff more, but it's tough because you can be a tech and maybe get a little bit less creative liberty. Whereas you can be an engineer and get more creative liberty, but you don't really get your hands dirty so much. I sort of managed to, in my career, do a little bit of both. But I think the part that interests me was more the cars than the engineering. I don't think I would be an engineer if it wasn't for cars.
Fair enough. In terms of that degree, becoming an automotive engineer, what does that actually encompass? Because I mean, as you just mentioned, there's a lot when we talk about cars as an industry, and the engineering also, I can imagine, differs as well. So, do you specialize in a particular area of automotive engineering, or is this actually all-encompassing?
Well, I started out my career working for a Nascar team where I did a lot of engines, internal combustion engine stuff, a little bit of aerodynamics, but mostly engines. And then worked for a valve train company, and then worked for an electric vehicle company, which obviously has nothing to do with internal combustion. But most of my career maybe was around prototyping and early stage engineering, but I've sort of been all over the map.
Let's talk about some of those work experiences that you had. Nascar, I mean, that's got to be an incredibly interesting place to work. Particularly, as I understand it, obviously we don't have NASCAR on this side of the world, and I'd admit my knowledge on NASCAR and the rules is relatively limited, but I mean, it's an intensely competitive race series. What were you actually doing in terms of the engine development work?
So I was with a team that was a relatively new team. And so we were trying to figure out a lot of the stuff that the other teams had known for a while. I was working on a little bit of tuning the camshaft timing independently on each cylinder, because you have you don't have equal length intake runners. You have at the time it was a carburetor in the middle and 8 runners going out that are all kind of different lengths. And with the firing order, you have just kind of weird harmonics. So you end up getting different airflow at different RPMs on different cylinders. So we're kind of like trying to optimize that. The reason I left that team is because they realized how much development was involved in that and ended up just leasing engines from a competitor. It was fun, but it was challenging because one of the most interesting things we did was we did a wind tunnel test. The year I was there was the first year of what at the time was called the Car of Tomorrow, which had a separate wing on the rear and had a front splitter sticking out. And the first year, the front splitter only had a handful of rules. It was basically, here's the shape. You have to have these 5 supports in these locations. And we figured out that it's basically a parachute at Talladega and Daytona at the super speedways. And so you could make the supports however you wanted. So we went and bought like massively oversized fasteners and turnbuckles to make the supports, knowing that would sort of like it would sort of push air around the splitter area that was acting like a parachute, and you could go a little bit faster. But the challenge was like not necessarily figuring that out. It was figuring that out and then getting it past technical inspection in a way that made it look like we didn't just spend $100,000 at the wind tunnel. It made it look like we put it together in a shed somewhere. It was just like clunky, and it looked like we were making a mistake more than
But you'd done it for a very specific reason.
Yeah, which is an interesting challenge, but it doesn't really apply to. There's so much stuff in auto racing that just doesn't apply anywhere else except for like sometimes 1 or 2 tracks or 1 or 2 cars, and sometimes just one season. So yeah, there's a lot of that.
I can only imagine as well with NASCAR, for a new team, the financial resources required to get up and running and compete with the big players would be mind-blowing.
Yeah, we were always pretty happy with just qualifying for the races, just being on the track. So yeah, there wasn't really. It's also interesting. It's something like, I've never worked in Formula One or any other series, but it's my impression that if if there's a rule and you figure out a clever way around the rules, you can exploit that. Whereas NASCAR, it seemed like at the time, I don't know if this is still the way it is, but it seemed like you could find a clever exploit in the rules and they would just tell you to take a hike. You show up with something clever that meets the rule, the letter of the rules. They're just like, no, you can't do that. So it's kind of like
that's got to be pretty frustrating.
Yeah, it's more clearly just like about the driver personalities and advertising and stuff like that than it is about the car, which is of course true with every racing series to some extent.
Yeah, I'm a big fan of Adrian Newey's book, How to Build a Car. And that's his autobiography. For those who haven't read it, it's a must read. It's insanely good, but it goes into depth with each of the major rule changes that they had in Formula One during his time, and how he would basically exploit, would you call it loopholes in the rules? Maybe not loopholes, but there's the way the rules can be interpreted, and sometimes what the rule says is not necessarily what the rule intends. And there's a disconnect there, and he's famously exploited the rule book a number of times to get massive advantages. But in Formula One, unlike what you're saying there with NASCAR, if it meets the letter of the law, well, that's locked in, and they can't change that, at least for that season usually, unless it relates to safety, which is obvious. So yeah, very different series, obviously.
Yeah, and I guess it's kind of the dream for all the race car engineers to have as much design freedom as possible, and to be able to exploit as many things as possible. And it's like, to make the field even and to make the racing interesting, that sort of like is at odds with that.
Yeah, definitely. I think one of the things that he mentioned in his book is, I think, a frustration to him is with Formula One particularly, that they're making more and more rules about what bodywork you can have, where that bodywork can be, the shape and the design of that bodywork, to the point now where, in his own words, if you painted all of the cars in the field white, you'd actually have to be a genuine guru to be able to tell which was the Red Bull, which was the Ferrari, etc. So I think in a way that's actually a shame, because it takes away some of the ability for the teams to make technical advancements and gain an advantage from that, which I think was always one of the benefits of Formula One to me. But I digress. We're talking NASCAR here, not Formula One. So how long were you in NASCAR, and what was it that sort of made you step away?
It's only there it was less than a year, somewhere between 6 and 9 months. And like I said, they started leasing engines from a competitor, and they sort of scaled down their engineering department way back. It was more just like it was owned by the guy. It was Furniture Row Racing, and it was owned by this company, Furniture Row, which basically just an advertising thing for them. Like I said, we were just happy to be in the race, not really competing to win, which isn't exactly what I was looking for. So I ended up going to Del West, which was one of our suppliers at the time. That got me out to California. Did that for a couple of years.
So Del West, valve train parts manufacturer?
Yeah, they do NASCAR, Formula One, Top Fuel. I think we at the time were doing like Corvette Z06 intake valves and some higher performance production stuff. A lot of titanium.
Okay. And what specifically is your role at Del West?
Man, I did a lot of just manufacturing stuff. It's funny. I haven't thought about that job in a while. It wasn't particularly interesting, I guess. Yeah, a lot of little manufacturing projects, trying to figure out how to get sodium in the exhaust valves with a lower scrap rate, and trying to get, like a lower scrap rate on the titanium nitride coated valves, stuff like that.
For those who maybe aren't sort of up to speed with valve trains and valve construction, can you talk us through the sodium-filled exhaust valve, why that's done, what the relevance of it is?
Yeah, it just sort of pulls heat away from the head of the valve, and kind of, the sodium inside. It's a hollow valve with sodium inside it, and it sloshes back and forth, and you have incredible heat in the combustion chamber on the face of the valve. And the sodium helps kind of like bring that back to the stem of the valve and distribute that heat back into the engine block through the valve guides. So you can kind of run a little bit lighter valve, because you can run a little bit cooler in your valve.
Okay. So without that sodium-filled valve, you're reliant on the heat being transferred through the valve seat when the valve's closed. And obviously there's still going to be some conduction of the heat up the valve stem and into the valve guide, but this just improves or increases the amount of heat transfer into the guide. Am I reading that correct? That's
the way I understand it. I mean, to be completely honest, I didn't design the valves. I did more of the manufacturing process, like I said. But yeah, that's the way I understand it.
Okay. So after Del West, what's next in the lineup for you?
Then I went to a small startup company that was in California called Tesla. That
haven't heard of it.
Yeah, well, you might not have at the time. Well, you might have, but we were at the time just starting design work on the Model S. So we had the Roadster out, which was frankly a pretty terrible car. Not bad for a first effort from a startup, but that was a very interesting time, because it was when I started working there. All my friends were like in the automotive industry. All my friends were like, "What are you doing? Nobody's going to buy electric cars." And they're sure as hell not going to buy them from some startup that nobody's heard of in California. And then 5 years later, when I left, everybody's like, "Oh yeah, of course, everybody's going to buy electric," and we're all moving to electric. And of course, Tesla's way ahead. So it was an interesting. There's an old saying, I forget who said it, but it was might have been Douglas Adams, but it's all truth goes through 3 stages. It's ridiculed, and then it's opposed, and then it's accepted as obvious. And I feel like this sort of electric vehicle transition, I kind of like got that firsthand from the inside while that was going on. I'm still not 100% sold on EVs. I think hybrids are probably a big solution for a lot of people for the next few years. But yeah, it was a really interesting time.
No, let's dive into that, because it is a divisive topic. I'm not quite sure exactly where I sit on the EV situation either. Obviously, they've really taken over in the last sort of 10 or so years, and we do probably have Tesla and Elon Musk to thank for that. It's sort of, in a way, a bit of an environmental red herring in a lot of places, a lot of countries, I feel, because yeah, we're powering them with electricity, but in a lot of countries, that electricity is being produced by burning fossil fuels, so you're kind of just moving the problem from one place to another. Now, yes, of course, we move to completely renewable energy sources. That's going to change. So I don't necessarily, I'm not knocking EVs, but yeah, interested on your take on the hybrid versus EV situation.
Well, I think electrification is worthwhile because even if you do create the electricity with fossil fuels, with coal or whatever, you're like wheel to well. Your total emissions are lower. You have a lot of places like the northeastern United States where they get so much electricity from hydro, renewable resources like that it makes a lot of sense. But there's a lot of trade-offs when you get an electric vehicle. The towing, hauling around a lot of heavy things, driving long distances. It's a great, like the Model Y is such a great car for so many people. It's the correct solution for a ton of people, but it's just not the correct solution for everybody. And I think that you end up with, if you're using your car for a little more utilitarian stuff, I go off-roading a lot, I'm towing a lot. I think Toyota's got kind of the right direction with something like the new Prius is, the Prius Prime, I think, is pretty great. It's pretty cool because they have this, was like 43 miles of plug-in range, decent power, and it still has the internal combustion engine. It's not too expensive. So it's like you basically get an EV 99% of the time, because how often do you drive more than 43 miles in a day? But you have all the benefits of internal combustion as well. So yeah, I think it's just like one of those things that depends on what you need your car to do. And I think for a big chunk of the world, EVs are just not quite the solution.
Sure. Yeah, I do think the plug-in hybrid combination, where you do have a certain range, that is going to be a really good option for a lot of people, because as you say, that for most of the time is going to cover your day-to-day commute, obviously depending where you live, but for a lot of people just in and around town, you can do that on full EV, and then you've got the benefit of the internal combustion engine, so you don't have that range anxiety. So yeah, I agree. The flip side of that I always look at is, now you've got all of the complexities and potential reliability problems of an internal combustion engine, plus you've got the complexity of the hybrid system as well. So are you introducing more potential problems than just going full EV or full internal combustion?
Yeah, I mean, probably. Cars are so complex these days anyway already that it's not like you have a simple thing that you're overly complicating with the addition of a electric motor. And like it or not, cars are they're disposable commodities. They're sort of all designed to last 10 to 15 years and 200 to 250,000 miles. And if you can design a complex system to survive that, like, it's going to be functionally and practically as good as anything that's simple that's also going to survive that.
Yeah. 10 years, yeah, I think that's probably fair. I think as cars have become more complicated, there are just simply more electronic systems, for example, to go wrong. I'd argue that Jaguar Land Rover maybe have their value proposition a little bit skewed. Unfortunately, my wife drives around in a Land Rover Defender, and I think that spent 2 months in the last 2 years in a workshop being repaired. So I can't say that, that's 4 years old now. Maybe they've got some work to do. Anyway, again, I'm sort of going a little bit off track here. So let's get back to what you're actually specifically doing with Tesla.
Sure. Yeah. I mean, I started in the thermal management team doing just integration, just packaging basically. And then when they bought the factory in Fremont from Toyota, I sort of stayed in Los Angeles in the design studio doing design studio engineering, which is, the designers would come up with a crazy idea like, hey, let's make the rear door go up like, and then I'd have to figure out how to actually make that mechanically work. I do the engineering on it. So it was really fun because it's a lot of kind of wild stuff that just didn't exist before. but really challenging. It's one of those places that like I'm really glad that I was there, and I really enjoyed working for Tesla, and you could not pay me enough to go back. So it's like,
Yeah, those are some very opposing views.
yeah. But I mean, it was fun. It's just very challenging, and it was stressful. We'll say that. Yeah.
Yeah. Just a lot of time crunch pressure.
A lot of time crunch pressure. So the way like Elon runs that thing actually, I don't know if he still does, but at the time he was like very involved, and he has this way of sort of breaking things down to their first principles. He breaks things down to actually, this is a really interesting story. So my first meeting where I presented to him, we were presenting the heat exchangers on Model S. And we had three different, option A, option B, and option C. And I forgot what they were. It was like, it was the main powertrain heat exchanger, and then the two heat exchangers for the air conditioning. We had them split up into different orientations in the front of the car. And I gave the presentation, showed the CAD, and he said, I must have said 3 times that I wanted it in the back of the car or something to that effect. Because he wanted it like a 911 Turbo, has the intercoolers that are sort of in the back, the inlets above the rear tires. And he flipped over a piece of paper and he pulled out his pen and he said, okay, well, the motors are making X horsepower. They're this efficient. We're going to be using on average this much power. The forced convection heat exchanger equation is this. So therefore the radiator should be this big. Why is yours 4 times bigger than that? And at the time, we explained, we're like, okay, well, if you like gross vehicle weight rate the car, if you pile up the car with people and stuff and you drive up Baker Grade in Nevada or in California at 115 degrees outside with the air conditioning on full blast, and then you plug it into a supercharger, like this corner case requires, and I thought it was really interesting because at the time I was like, wow, that's really impressive that he had memorized this thermal management equation. And I thought later, I was like, I bet he didn't. I bet he, before going into that meeting, was like, okay, I'm going into a meeting about the radiator. Let's Google
let's do my homework.
Yeah. And do get the most basic equation. And if engineering, like I always say, engineering is kind of like when you go to engineering school, you learn that if you have let's say you have a pole sticking off the side of a building with a weight hanging off of it, you can calculate the stress in that pole, right? That's one equation. That's the sort of the fundamental base equation. But if you have notches, you have notch sensitivity. If you have a coating, that's going to affect it. You have thermal expansion that's different between the brick wall and the pole. You have all these these little equations that sort of add on to the end of the main equation. That's where the real engineering is. That's where the sort of meat and potatoes of engineering is. Elon's very good at just doing that first big equation and then making sure that his engineers did all the other little equations.
I mean, I think that's the key for any CEO in a big company that's successful, though, is you don't have to know everything. And the key is you employ people that are smarter than you are.
Yeah. And then he double checks to make sure. But the frustrating thing is that I think that makes him a pretty good engineering leader, makes him a pretty great engineering leader. But it also makes it frustrating because cars are so complex. And there are even just subsystems and parts of cars are so complex that it's like whenever something needs to, whenever he picks a timeline, he picks it based on just the most basic. He doesn't think of all the little things. When you build a factory, it's like, how long does it take to the concrete to cure? How long does it take to put the walls up? How long does it take to run the electrical? Okay, should have a factory running in 6 months, right? Or a little shorter. So it sort of makes for a stressful environment because the targets are always sort of impossible to hit and makes for a lot of late deadlines. And I've heard it's, chilled out a lot. I left 10 years ago, so it's been a while. But at the time, it was pretty rough. Also really fun, though.
Yeah, it sounds like a typical startup culture.
Yeah, definitely.
I've talked to other people who have been involved as engineers with mainstream auto manufacturers, and the stories I generally hear they spend 2.5 years working on the left-hand tail light for whatever car it is, which personally I couldn't think of anything worse. So obviously from your stories, Tesla was the complete polar opposite of that, and you really did get involved in some pretty interesting things, though.
Yeah, and I don't know if I've never worked in a company that works that slow. I don't know how I'd handle that.
I may be exaggerating, but the reality still, that's the sort of thing I hear.
Yeah, and you working with suppliers as at a company like Tesla, you end up seeing a lot of that sort of very slow, deliberate way of doing things that Yeah, it's certainly not exciting. And then, yeah, so I think there's maybe a middle ground that is a more, more ideal place to be, but certainly it was very exciting. It was, like I worked on the Falcon Wing door on Model X, which is, looking at it, it's like, all right, it's kind of goofy and adds a lot of complexity unnecessarily. But also it's like, I had been at that, my career was like, it was like 4 years into my engineering career, and I got to do an entirely novel door. Like people spend their entire careers in automotive and just do the same thing that's always been done. So, it was sort of great in that respect.
I can only imagine it's probably pretty satisfying seeing a Model X pull up to a parking lot and the door go up as well.
So I did the early engineering on that. I did the prototyping and the early engineering. And what happened was we showed the Model X, and then I was supposed to sort of hand it off to the closures team, to the door team, and they were just completely drowning in Model S production, trying to get that going. And it took a while, and there was some like people who left and people who got fired and new people who got hired. So it was like I'd sort of like try to hand it off to somebody, and then they'd leave the company, and then I'd try to hand it off to somebody else, and then the director would fire somebody. So it was like it was kind of a headache getting it moving, and it was sort of obvious from the get go that it was a major challenge in control systems and in controls and in the overall body, right? Because you're taking out the cant rail, you're cutting up a huge chunk of the body. And so finally, like I got to hand it off, and then they took it, and then it just became this kind of major pain in the ass for everybody because it was such a big tear up to the body, and the control systems was it was like frustrating to try to like keep that thing moving, and it still just became a giant headache. But so I don't know. I have mixed emotions about it.
Fair enough. All right, moving on. So what comes after Tesla?
After Tesla, I took a little bit of time off and got a call from Apple. That was kind of interesting. I was skiing. I took a couple of months off. I went to Colorado, rented a room, and just was snowboarding. And Apple called me up and said, "Hey, we want to talk to you." And I said, "Well, I'm going to be in that area in a couple of weeks. Why don't I just swing by?" And I showed up in a t-shirt and jeans, kind of just thinking it was a chat. And they had set up a full interview, which actually turned out to, I think, work out in my favor because it sort of like gave this relaxed kind of sense of, I don't know, whatever. But anyway, they interviewed. It seemed like a cool project. That I don't even know how much I can talk about that because the team Apple's like super secretive about everything they want. They don't want anything to be known about a product until they, demonstrate, until they show it, and they can kind of control everything. So they were like very serious about like, don't tell your spouse what you're working on. Don't tell them even what the like basic thing you're working on is. And I was like, all right. So I grew up working on cars. Once I got a car, I was working on my car all the time. Went to college to work on cars, built race cars in college. I write about cars. I build cars. I work on cars in my spare time. Worked at a car company, worked at a race car company. Then I went to Apple.
Yeah, it seems like quite a departure. The project potentially that's just been canned completely in the last few months, at a guess, without trying to throw you under the bus and break your NDA. I want to actually take a step back though. How do you get on Apple's radar in the first place? That sounds quite a stretch to just get a phone call out of the blue from Apple one day, come in for an interview.
Well, they were building a thing on their product that I was working on at Tesla. So they needed somebody in that department.
All right. Well, again, with the NDAs, etc., I don't want to put you in an awkward position, so we can probably just imagine what you're up to there. All right, let's sort of fast forward to your current occupation and probably the way most people would know you, your YouTube channel. So how did that come about? I mean, that seems like quite a leap of faith to decide that becoming an automotive YouTuber is going to be the way you're going to make a living.
Yeah, so I took some time off. After I left Canoe. I did a little bit of writing for Jalopnik and trying to do a little bit of automotive journalism type thing because I've always been interested and I've always liked writing about cars and making videos and stuff. I've always enjoyed the sort of, I hate to use the word journalism, but that kind of side of it. And right about then, COVID hit. I guess before that, I'd made a handful of videos and I put them up. And then COVID hit and everything got shut down. And it was like, okay, everybody go home and sit in front of your computer and do your engineering. And the thing I like about engineering is going to a place with people I like being around and building an actual thing. So when it just became everybody's going to go home, and then this work from home thing's going to extend, and I was just like, well, maybe I can put a little more effort into this YouTube thing and see if I can make it take off. And yeah, I mean, it's been pretty steady. It's been just a pretty steady increase. There's been a few videos here and there that have kind of like bumped it a bit, but it's been pretty nice. I definitely still don't make as much money as I was making engineering, but I get to do whatever I want, whenever I want. So it's hard to beat that.
Yeah, I mean, money is definitely important to a point, but you do have to trade that off with your lifestyle as well, and being your own boss and being able to do whatever you want. There's definitely a certain value in that. The time we're talking, I think you're a bit over 410,000 subscribers. How long has the channel been in existence, and how long did it take to get to a point where it was actually producing you enough income to fund your lifestyle?
Let's see. So I had actually made a couple of videos like 10 years ago, and I put them on my channel, my personal channel. And then when I started Superfast Matt, I don't remember exactly how this works, but I think I got to either I changed the name of the channel or I like rolled those videos over or something. So I basically started the channel with, I don't know, 100,000 views or something like that, and a few subscribers already. So it was kind of like a little bit of momentum out of the gate, which I think really helped, especially at the time when everybody was stuck at home and all they could do was watch YouTube. And I did a pretty good job early on of keeping the projects relatively inexpensive. They're still not too expensive. So like I have a Tesla powered Jag. I got the Jag for about 10 grand. And I think the powertrain was about 10 grand. And that was like, I don't know, 9 months of videos. So, there's probably 30 grand worth of stuff in that in 9 months, which is not that much money for so it's like I was making enough money to pay for the projects, which I thought was like the coolest thing ever at the time. It's like, I can do goofy projects and get them paid for with videos. And of course, now I'm at the point where it's like, all right, the projects are a little bit bigger and I can actually also use that money to pay rent and stuff like that. So
yeah.
Yeah.
Do you think there's an importance or relevance in doing projects that aren't sort of $200,000-$300,000 worth, so that your subscribers can actually relate? What I mean is, it's something that they could look at and go, hey, you know what? I could actually do this. I don't need to be, earning $200,000 a year to be able to afford to do it.
I think there's a value in being honest about who you are. And I guess if I had just tons of money, I might be lifting a more expensive car. So, I might be doing more expensive stuff, but I think I'm just honest with the way I do things. I don't have any interest in supercars. I've never really been you could park 5 Ferraris next to each other. I couldn't tell you which one's which. I think there's probably some connection there with people who are a little more down to earth, but I think there's value in being genuine and presenting what you are interested in. I think maybe more so.
I relate back to when I was drag racing and we had my Evo 3, which was, by the time we sort of retired it was definitely not a cheap car. It had a lot of money poured into it and a lot of blood, sweat and tears. At the same time, my old road car was a K70 DX Toyota Corolla, and that had been caged at that point, and it had a 4AGE or 4AGZE bottom end and a silver top 20 valve head, and it had a hand-me-down turbo off my drag car, and it really was cheap and cheerful. It sort of had a rattle can spray paint job. There was nothing on it that was expensive, and it was all done, basically in the back shed. And it was interesting because we'd take both cars along to one of the bigger car shows here in New Zealand, and the DX Corolla actually got more attention than my Evo. And I always put it down to, obviously the enthusiast market that was coming to these car shows was the sort of 15 to 35-year-old, and they could relate more to, hey, that DX Corolla, I could actually own that. I could afford to buy it and build something similar, whereas the Evo was just kind of, a bright, shiny object. It was nice, but they couldn't relate to it. I think there was something of that, and I think that's what I was getting at with the YouTube channel. I think it's important to do projects that are relatable.
Yeah, I think so. So my first couple of videos was about my Honda. I have a Honda S600 that I bought for $1,700, somewhere around there. And I dropped a motorcycle engine in it. And I got ran into Jay Leno while I was driving around. It's like must be 10 years ago now. And he invited me onto his show, Jay Leno's Garage. So there's a video of that where I look 10 years younger than I do now. But that car is great because I probably got a little bit more in it now, but I think I did that whole project for less than $10,000. It was pretty cheap. You know, it was like for a car that's like a big project like that, where I swapped out all the suspension and basically the entire powertrain, to do that for like whatever, $7,000 or $8,000 is pretty scrappy. And I'll take that. One of my favorite things to do with that car is to take it to car shows, especially in Los Angeles where there's a lot of money floating around. And I'll go to a car meet and I'll find the row of McLarens and Ferraris and I'll park at the end of it. And I just sit there and I'll watch people walk past $10 million worth of cars to look at my rusty old Honda. And I love it so much.
Super satisfying.
Partly because I built it, but yeah, it's just, I think it sort of also says something about like, you know, I think people appreciate something that's a little creative and different. Also something that's like approachable. Of course, the S600 now is like, the prices have gone through the roof. Maybe not mine because it's rusty and all torn up, but I think you're right. I think people do appreciate something that's a little more like accessible to them.
Yeah, definitely. And I think we were probably into that DX Corolla at the end for probably about maybe 20,000 New Zealand dollars. So I don't know what the exchange rate is. Call that maybe 14,000 US. And at the end, it ran a 1051 at 134 mile an hour on the quarter. I mean, I can't say for sure, but there's not going to be a lot of vehicles you could buy that are going to run 10.5s on the quarter for 12 or 13,000 US dollars. It's not going to happen. I think there's something real satisfying about building a supercar killer as well, particularly one that, you know, on face value, it looked like a bit of a piece of shit, but, you know, I was pretty proud of it. Okay, how challenging is it to work with that YouTube algorithm, this unseen YouTube algorithm, and produce videos that consistently perform well?
You know, I don't. People will ask me sometime, like, how do you, like, what's the secret, or how do you get followers, how do you get viewers? And I actually I never know how to answer that, because I don't know if there is a trick. I think you just have to, like, if I write a script and I don't like giggle to myself at least a couple of times while writing it, if I don't like laugh out loud while putting the video together, I'm like, what's the point? You know, it's like, I don't want to make bad videos. So I think it's like, if you make a video that you think is good, that you enjoy, that's, you know, it's not boring, it's not slow, you know, it sort of has a story to it and it conveys something that you're interested in, then that will get people to watch the video. You need a good thumbnail. The thumbnail is actually hugely important. Thumbnail and title are really important, which is a whole conversation on its own. But beyond that, if you can make a video that people, once they start watching it, they want to watch it to the end, then YouTube, that's what the algorithm is seeing people do that and then being like, oh, I bet I can show this to 10 other people and some of them will watch it all the way to the end. And then 3 of those people do, and they show it to 30 more people, then it just kind of goes from there.
So basically you want to avoid the videos that people get into, watch for 30 seconds and then bounce, because that says that video is not interesting. So they're not then going to present it to more people.
Yeah. I mean, I've heard people before in the past say that it's bad to try to like, whatever, pay for subscribers, or to try to like get people to subscribe who are not like really into your videos, because then they'll do that. They'll click on it, or they'll get shown the thumbnail and not click on it at all, or they'll only watch the first few seconds and click away. And then that's sort of like, it doesn't make the video look good to the almighty algorithm. But yeah, I mean, I think it's just make good videos.
Yeah. I always find it a little bit frustrating because we put a lot of effort into our videos. I mean, they are technical in nature, probably a little less comedy than yours include, which I think is probably one of the areas where you really succeed. And we'll produce 2 videos that I believe equally good. One of them's had a huge amount of effort put into it. You know, it'll have animations from our guy Sam, you know, all the bells and whistles, and it kind of just goes flat. And then we've got one in particular that a guy no longer works for us, Tim, did on brake pad knockoff. And it was just filmed vlog style. This was, I think, over lockdown, so there was a limit on what we could really do. No production effort, and it just blew up. And I think that video's got over 1 million views, and sort of left scratching your head going, why? It's confusing.
Yeah, so my number one video in views, I almost didn't make. people will say stuff like, "Oh, your video has to be at least 10 minutes or else it won't get picked up or whatever." And I think it was like 6 minutes long. And I happened to be driving through Death Valley right after a big rainstorm came in, and I had my Forerunner, and I was towing people out. And I was just kind of like showing, hey, Death Valley's, totally wrecked. And here's a river flowing across the road. And here's me towing some people out. Whatever, stupid fun video, put it up, expected it to get fewer than average. And it's at like 5.5 million now. So like, like when I look back on that, it's like, okay, it was a big story. It's sort of compelling to a broader audience. It had a pretty good thumbnail and title. It was a fun little story. It was, obviously like half the video was the dash cam from my car. So like, I actually think production quality is probably overvalued. I think you can watch Mr. Beast, who has he's one of the number one YouTubers, and he'll do these crazy zoom in shots where it's like the quality of the video goes really bad for, a short time. And I'm like, okay, he's not worried about pixel density or whatever. I think well, actually it's kind of like what you were saying before. Like people are attracted to cars that are in sort of their socioeconomic or their economic range, something they can relate to. And I think it's a little bit the same with videos. If you do something a little too produced, it sort of, I think, maybe alienates people a little bit. But I will say, like, in general, if I look at all my videos, if I sort them by view count, I tend to personally really like the ones that have more views, generally speaking, than the ones that have fewer. Like, I think that they're better. I would just be like, that's a better video. So I think that there are surprises and there are weird things that happen, but I think in general, what I would consider my best videos are the highest performing videos.
Yeah. Yeah, that makes sense. Okay, so there's probably a lot of people listening to this who are thinking that becoming a YouTube sensation is going to be easy and a viable way of making a living. What would you say to those people?
It's harder than it looks. I love most aspects of it. Like, I get to go out in my garage and make a goofy project, and then I get to make a video about it. I get to write the video. I get to edit the video together. I get to come up with a thumbnail, and I get to put it up. And I genuinely really like all of those things. And I think you kind of have to. And you kind of have to be good at all those things. There are aspects that I've sort of like figured out over the time, like audio. I'm sure as you know, audio is harder than it seems.
Much, much harder.
And it's not one of those things that I'm particularly interested in, but I kind of had to figure it out. I would say if you are interested in doing YouTube, you should probably make 10 videos. And then after you've made 10 videos, see how much you enjoyed making those videos. And if you had a good time making those videos, keep making videos. And I think like if you're a young person or you're like in college or you have some spare time to like make videos, you can probably do it with the hopes of someday maybe making it to the point where you can make enough money doing it, as your main source of income. But I average probably 200,000 views per video, which I think is pretty decent. I'm fairly well known enough that I can go to a car show and 4 or 5 people will come and talk to me. And I think I'm trying to find the words for this because it's like, all right, Mark Rober, I used to work, Mark Rober, the YouTuber, he's so I used to work with him at Apple. He quit Apple to do YouTube full time and he's got like 25 million subscribers. So I'm doing YouTube full time and I've got 400,000, but the difference between that is 2 orders of magnitude. Like the amount of money he's pulling in is enormous, right? So like if you cut me and, if you go in 1 order of magnitude lower than me, you're going to be where I was 3 years ago, where you're like, oh, I have a $30,000 project and I may be able to make enough money over the course of an entire year to pay for the project. So it's like, I don't know, do you want to be a professional YouTuber? You might as well say you want to be a professional rock star or skateboarder or whatever. Like maybe you can do it, but it's like,
you're talking the 0.1% of the population that's actually going to make it at that level.
Yeah, I just think if you're doing it because you enjoy it, then maybe you can be successful. If you're doing it because you're trying to be successful, you're probably not going to be successful. And you're probably not going to enjoy it either.
Yeah, no, I think that's pretty good advice, really. All right, let's move on and talk about some more tech topics and the stuff that you're producing on your videos. Obviously, a lot of the things that come from your background in engineering. And I want to start by talking about 3D modeling, 3D scanning, and 3D printing, and the relevance of all of these technologies and how you've seen them develop over your career and how you're incorporating them. For a start, I mean, a lot of enthusiasts who don't have a massive budget would probably look at some of these technologies and think they're out of reach or just not relevant to their own projects. I mean, what would you say to that?
So CAD has reached this point where you can get free CAD software from a few different places that will do a lot for you as a hobbyist. CAD is one of those things that's a little tough for me to talk about with respect to like whether or not you should jump into it, because I've been doing it for 25 years. I've been doing it for so long.
So it's just second nature now.
Yeah, CAD programs. And I've had a few people ask me, they're like, why don't you make a video on how to do CAD? And I was like, I'm so like, that's a video that would be excellent for somebody to do who is just learning. It's not a video that's good for somebody because I'm like, I don't know what's not obvious and what's not intuitive. And also I have so many bad habits that I've built up on it, but it's so powerful. I would not build something more complicated than a bar stool without a CAD model at this point. It's like I just CAD everything because it makes it so much easier to make mistakes in the computer quickly and then not have to make them in the real world. And you can make things, you can just make them faster and better. So I just got a 3D printer. I put off getting a 3D printer for years because I used them 10 years ago, 15 years ago when they were garbage, and you'd print something and 2/3 of the time it would just be a spaghetti mess and the quality of the material was bad. But they've gotten to the point now where they're pretty reliable and there's so many different filaments you can get. And I bought one thinking, I put one off partly because I didn't want to deal with a mess, but partly because I was like, what am I going to print really? Like, what am I actually going to print? Since I bought it, it has been running more than half the time. Like it's just constantly printing stuff. And I found that it's really great for functional parts. I build a lot of stuff with my Landspeed car has electronic boxes and a few other things made out of polycarbonate. Polycarbonate's great. You need an enclosed printer. You need a little bit better printer to do that, but it's like it's ridiculously strong compared to like my mind's eye still sees the way 3D printing was 15 years ago where everything just crumbles and cracks. But like nylon, carbon filled nylon, like I was consciously trying not to turn into a 3D printing nerd, and I have fallen just deep into 3D printing nerddom. Like I've got this right on my desk right here. I've got this latch that I just prototyped for a parachute release for my Landspeed car. Just because it was like the 3D printing is sort of like a next step from the CAD model. You sort of make some mistakes in the CAD and then you just print it and put it together. And you're like, you don't even need to actually use it. You can just sort of play with it and be like, oh, I should make this thicker and make this thinner. So yeah, printers are all over. Like my printer it's $1,000. It's a pretty expensive printer. And I think that's probably unnecessary. It's definitely unnecessary for prototyping stuff, for the type of stuff I just showed with the thing.
Yeah, I just wanted to talk about that. I mean, you can use the 3D printer for prototyping, like you've just explained. And I mean, that makes a lot of sense because you're making the part, particularly if you're making something that ultimately is going to be CNC machined out of billet aluminium, prototype or making that part and finding out you've got a dimension wrong or there's an interference or something like that when you go and fit the part up for the first time, that's kind of an expensive throwaway item. Whereas it's relatively quick and cheap now to just prototype the part with a 3D printer and find these issues beforehand. But then how useful are these now for printing for a part that's actually going to be used on the car? Obviously, you mentioned your polycarbonate boxes that are on your Landspeed car. So there are applications where this can actually be the final part.
Right. So that's like, I think the difference between the lower cost printers and the higher cost printers is like being able to print something that requires the heating and the enclosure for filaments like polycarbonate. I think you can get 70 or 80% of the value with a PLA printer that you can sort of get the basic shape and then make it later in metal or whatever. But yeah, I have the Landspeed car has, I don't know, probably 15 parts, maybe not, maybe a dozen parts that are 3D printed that are like functional parts. And I think it's one of those things that's like you kind of just have to keep it in the back of your mind as a tool in your tool chest. Of course, all of those parts I would have found some other way to make.
Naturally. I think one of the things, though, with the benefits of having CAD software and knowing how to use it, and then a 3D printer, and again, knowing how to use it, is you can just up the level of quality and professionalism with your project. So you can just do stuff that 10 or 15 years ago when I was building my drag car, 15 plus years ago, I should say, that technology just wasn't available to us. And there was always little brackets and tabs that I was making that I just was never really happy with. I just wanted a nicer way of producing them, but that just wasn't available to me. So I think these technologies, just for the enthusiast, as you say, CAD software in some instances free. The first 3D printer that we purchased was under 1,000 New Zealand dollars, so I guess that's probably $500-600 US. We've just literally taken delivery of a new enclosed bamboo 3D printer. That's definitely up a price point. It does a different job. Can you talk to us a little bit about the different materials? And this is definitely not my area of expertise. This is Connor, who does our 3D CAD course. That's his specialty. But the different materials that you can print with, and maybe give us a quick rundown on pros and cons where they can be used.
Yeah, so I've just kind of started diving into this myself, so I don't know this super well, but in fact, it's kind of frustrating that there are so many materials, and there's like different versions of materials, that I've kind of fallen back on like 3 or 4. PLA is great because it's super cheap, and you can just get it anywhere and print it on anything. So for something like I just want to see how it looks in 3D. Excellent for that. PETG is great for also pretty low cost, but a little more usable stuff. I like polycarbonate because it's about twice as expensive as PLA, but it's very strong and it's very heat resistant. So you can shove it in an engine bay, usually, depending on where it's at, and it works out really well. And then nylon is also really strong. And if you get carbon filled nylon, it doesn't make it any stronger, but it makes it more stiff. So like a carbon filled nylon is sort of like it's nice to have around if you just need something to be really tough, really robust, I guess is the right word.
Sure. I think understanding the heat limitations of the material you're printing is really important. Just remember, just not long after we took delivery of our Creality 3D printer, and Brandon designed up some nice little mounting tabs for Dutch connectors, and they just lock into the tab on the Dutch connector, and nice easy way of mounting them in the engine bay. But unfortunately, that material, which I think was probably printed in PLA, couldn't really handle the heat of the engine bay, even though it wasn't directly by a heat source. But no big surprise, a lot of heat soak in an engine bay, and after the first sort of trip to the racetrack, they weren't looking quite as nice as they were to start with. So definitely want to pick your material to suit the application. Yeah,
3D printing there's a learning curve, and that they call it a hobby, and I didn't want a hobby. I wanted a thing that made other things.
Yeah, that's something I was just literally this morning talking to Connor, because this bamboo printer's just arrived, so he's deep in the learning curve with that, and he sort of expressed it to me as you can buy a 3D printer that's at a cheaper price point if you're interested in always fiddling with your 3D printer and getting deep into how the 3D printer works and setting it up. Or you can buy a higher price point like the bamboo if you just want to press go and it produces the part faultlessly every time with no sort of work required for every print you want to do. Does that sort of match your experience?
Yeah. And that's what I bought. I bought the bamboo, and I think they've sort of changed the game a little bit, because most of the printers coming up before them were a little bit of turn the knob, twist dials. You kind of have to know what you're doing, but there still is a learning curve. It's still like I don't know. Like I said, there's so many materials that it kind of just gets frustrating to dig through them all. And that there's I've got one color of PETG that prints great with my settings, and then I got 3 other colors that I can't get to print, with the settings that I hate fiddling with it. I hate printing something and it gets stringy or whatever. And so many people love doing fixing the problems and fine tuning it. I just don't want to do that. I just want it to print. They're good enough these days, and there's enough materials that I've found that are pretty consistently good that I'm really happy I bought one.
I think the other thing that I'll put out there is, if your budget doesn't allow for one of the more expensive and more sort of seamless printers, well, maybe you're going to have to get a bit deeper down the rabbit hole of setting up these 3D printers and how they actually work, and that's probably just fine. There's different levels to this, and if the budget doesn't stretch to a bamboo printer, well, there are other cheaper options, but they come with some other requirements.
Yeah, for sure. And also, just to add a note to that, I got into this whole thing of looking at the printer I got because a friend of mine bought a much cheaper one. I wish I could remember which one it was, but he spent $400 on one that was miles better than what existed even 5 or 6 years ago. So it's there are printers out there where you're not going to be pulling your hair out for not a ton of money.
Probably also worth mentioning, just like any technology, this is constantly evolving. So what we're talking about now, in another 2 or 5 years' time, you're going to have a whole range of more advanced technologies, and all of these printers are just continually coming down in price. So basically, great for the home enthusiast, and watch this space. I just wanted to interrupt this interview for a moment and talk about a course that I think is really going to be suitable to anyone who's enjoying our chat with Matt. And that, of course, is our 3D modeling and CAD for motorsport course. This course is ideal for anyone who wants to learn the skills of CAD and 3D modeling. And there's so many applications, even in the home garage or workshop, where CAD can really take your project to the next level, particularly when you couple it with readily available technologies now, such as 3D printing, or for that matter, sending your finished parts off for CNC machining. This course covers the basics of CAD as well as design fundamentals, essentially what you need to know about designing components that are going to be fit for purpose, safe, and strong. We also cover the basics of solid modeling as well as sheet metal modeling, and this, in my opinion, is probably one of the most powerful aspects of a software package like Fusion. We also cover assemblies as well as analysis of your components. We also cover post-processing, including dimensions and tolerances, drawing notes and specifications, and creating exploded views for assembly drawings. We then move into some of the more advanced CAD topics such as surface modeling, simulation and FEA, generative design, and automated modeling. We also include information on 3D scanning and printing. And finally, we break everything you've learned down into a simple 5-step CAD design process. And this takes a lot of the confusion out of the process of designing a part using CAD software. This includes planning, modeling, analysis, prototyping, and then finally post-processing. As with all of our practical courses, we also include a library of worked examples where you can see that 5-step process being applied in the real world. This course is normally valued at $199 US. You can use the coupon code FAST50 and that will get you $50 off, bringing it down to just $149 US. And even if you use that coupon code FAST50, you are still protected with our 60-day no questions asked money back guarantee. Plus, at the checkout, you can also break that payment down using our payment plan to just make it a little bit easier on your wallet. Remember, absolutely no risk. If you purchase the course and for any reason decide it wasn't quite what you expected, let us know. You'll get a full refund of the purchase price. We'll put that coupon code in the show notes. Let's get back to our interview with Matt now. Now, another technology that sort of goes hand in hand with all of this is 3D scanning. And obviously, we use that term and straight away it puts people off. You know, you're thinking of sort of $100,000 machines for scanning and measuring coordinates. And obviously, there, again, are levels to this, not too much dissimilar to the 3D printer. And at the lower end, most current phones have, cell phones have LiDAR, and those can be used to scan components as well. Obviously with an accuracy hit compared to the more expensive products. But are you using 3D scanning? What's your take on this? Again, is this a technology that's viable for the home enthusiast, or is this more a sort of professional level product?
So I think we've just gotten to the point where your average garage tinkerer can get a pretty good 3D scanner and get a lot of value out of it. I think I've got 4 scanners. Intel had made these scanners. They weren't marketing them as exactly 3D scanners. They sort of did a bunch of other stuff too. I bought one of those that they don't make anymore that was pretty good for larger stuff. I can't remember the name of it. I've got a couple of less expensive ones that they're frustrating because they work if all of the parameters are correct, if the surface finish is correct, if the color is correct, if it's got the right lighting, if you can carefully move it around, for just enough time in just the right areas. Those are barely recommendable. It's frustrating because I think if you do CAD, if you're into CAD and you're into 3D printing, the 3D scanner is like a no-brainer next step, but you kind of have to spend $1,000 in my experience. And I have not tested all of them out there. I put up a couple of videos. I have 3 or 4 videos on 3D scanning, and I've got people email me a lot saying, hey, we want you to review our scanner. I kind of don't like doing review videos, so I've said no to most of them. But from all I can tell, there's the Einstar is about $1,000. That's the one I've got. That's the one I recommend.
Yeah, I think we've just purchased one of those as well. Connor, our 3D modeling CAD scanning guy, is currently working on a 3D scanning course which complements our existing 3D modeling for motorsport course. And again, just trying to get the products that are at a price point that are at least within reach of the average home enthusiast. You know, a $10,000 scanner might do a great job, but unless you're a professional, that's probably not within reach.
Yeah. So the company that makes Einstar sent me one of their $10,000 scanners to review, and I did a video where I compared it to the iPhone. It is way better. It is a fantastic scanner.
You'd hope so.
But it's I would say that their $1,000 scanner is like, for the things that I do, is 80% as good. And you can, like, I scanned the motorcycle engine in my Landspeed car, and it's like, oh, the detail on the $10,000 scanner is so much better. You can pick up bolt holes and like tiny words, and it's fantastic. But it's like, I borrowed one of these back when I was at Tesla. We had one of these, whatever, 50,000, whatever, many tens of thousands of dollars scanners 15 years ago. And I sort of like borrowed one weekend. Nobody seemed to mind. I took it home. I did some scanning on my Honda. And I kind of thought at that time, I was like, boy, in 5 or 10 years, this is going to be $100 or whatever. And here we are 15 years later, and it's like, no, that's still $10,000. So it's like a little frustrating. I don't know enough about the technology to know why. It's clearly a reason why they're still expensive. But I do think part of it is the economy of scale, is the fact that there's just not that many people. 5 years ago, there was hardly anybody who was like clamoring for a $1,000 3D scanner. And I think we're getting to the point now where it's like, oh, there's a lot of people that would love to use that, but just aren't going to spend more than a few $100s. So I suspect this, much like 3D printing, is like moving quickly enough that this is all going to be different in, like you said, 2 or 5 years.
Yeah, 100%. I think the technology will advance, but you're right about the economies of scale. I hadn't really considered that. I mean, you have to have a market big enough to be producing enough of these items to actually bring that price point down as well. But suffice to say, the technology is going to advance. The price of these products is going to come down. But I mean, it is also a case of choosing a product that suits your application. I mean, most people, unless you're sort of reverse engineering some very specific parts, maybe a hub or an upright or something like that, you probably don't need accuracy to better than 0.1 of a millimeter for most applications. So, even the cell phone scan actually does a reasonable job, but obviously the accuracy is going to suffer there.
Yeah. And there's, like, every time I put up one of these videos or talk about it, a lot of people will say the photogrammetry, where you just take whatever camera and you take several pictures and then you use some software to create the 3D model. You have to scale it because of the phone, you have to also scan a ruler or something to be able to get the correct scale. But I've heard good things about that. I messed around with it a little bit. It's a little more involved. But yeah, I don't know. I think if you're building stuff in your garage and you have knowledge of CAD, you should probably be figuring some way to dive into 3D scanning. The other unfortunate part is, like, I got a $1,000 scanner, but then it's like you have to have a computer also that's pretty powerful to be able to drive it. So it's not an insignificant investment.
Yeah, that's actually a really good point, because it's super easy to overlook that, but quite processing intensive. So you're going to need a computer with a decent graphics card, correct?
Yeah, and it doesn't have to be like a super, like, I don't know cost. I haven't shopped for computers in a while, but I imagine it doesn't need to be like multiple thousands of dollars. I think you could probably get away with something that's $1,000 or whatever, but maybe even a little bit less than that. But the space is moving so quickly that it's probably going to be half that price in 2 or 3, 5 years, something like that.
And if you need to sell the computer to the spouse or the other half, you can always sort of argue the case study that not only can you use it for 3D scanning, but it's going to make a perfect base for a simulator computer. So there you go.
Exactly.
Two birds with one stone.
Yeah.
All right. Another element that I wanted to talk to you about, which sort of goes hand in hand with everything we've been talking about, but is one that I don't see as often, is you've also got a CNC router in your shop. Can you tell us, for those who haven't heard that term before, what is a CNC router? Yeah,
it's just it's sort of like a CNC mill that is a lot less stiff and a lot less power. So it's sort of like, your CNC machine that can mill out blocks of aluminum. And just imagine that can only do wood. And it's kind of like that. It's considerably less expensive as well.
All right. So you can't machine aluminium with it. You're limited to wood or foam, which is another product we'll talk about.
So mine will do aluminum, just barely. And you have to use a one flute cutter. And I did a part that was sort of like the base plate for my intake on my Landspeed car that had radius inlets, like little trumpets, and I think it was like, I forget how much, but it must have been like a 6 or 7 hour cut, and it would have been a thing that probably would have taken 20 minutes on a regular, even like just a Haas or whatever CNC mill.
Sure. Yeah. Okay. So there's limitations that go with it, but as you mentioned, a much cheaper product than multiple tens of thousands of dollars, even for a secondhand entry level mill.
Right, exactly. Yeah, I got mine from this company called Onefinity. They're not sponsored or anything. I wish they were, because it's a great machine, and they have several different. You can sort of spend 2,000 or 4,000 or 8,000. I got the $2,000 one. I think you can spend a little less than that too. But it's like, it does so much. It does the aluminum. I did the entire interior dash for my Jag with it. I recut everything out of wood. I've done molds in foam, molds in MDF. It's pretty great. The only thing I don't like about it is that it's like the cutting areas, I think it's a little under 3 feet by 4 feet, 4 feet by a little under 3 feet, but it takes up 5 feet by 5 feet by like whatever, a foot and a half tall. And so it's like constantly at all times taking up 25 square feet in my garage, but that's really the only drawback.
Yeah. Okay. All right, so you sort of given us a couple of case studies of how you're using that. I want to dive into the foam in a moment. What are the added skill sets that you would need in order to take something you've modeled in Fusion and then actually create that on your CNC router? You're starting to get into computer-aided machining as well?
Yeah. So back in college, I ran some CNC stuff for the race car on this Haas mill we had using Mastercam, I think. And it's considerably easier today. Fusion 360 is pretty great with the cam. It's like, admittedly, I'm the kind of guy where if I'm not really interested in something, if I just want it to work, I kind of just like hit it with a big mallet until it works. Like, I don't really figure out the fine details. I just sort of like fat finger it until I get it to work. And I've kind of done that with the cam, the machining in Fusion 360. It's been intuitive enough that I've been able to machine a lot of stuff without, taking a college course on it.
Yeah, okay. Would I be right in assuming, though, that if you're using your router on the likes of foam, it's a fairly forgiving product, so maybe the tool paths don't have to be as precise and well thought out as if you're actually CNC machining a big block of billet alloy?
That is absolutely correct. In fact, the foam sort of comes in different thicknesses that, it says at 2 inches, some of it will be 1.9, some of it will be 2.1. And I was like stacking it up to 5-inch stacks, and some of it was like 5.2 inches. And I didn't bother to tell the computer that it was 5.2 instead of 5. It would just like quick, like rapid the end mill through the foam, and it's foam, so it doesn't matter. But yeah, if it was aluminum, it would have made lots of noise and probably cost some money. So yeah, and the wood, you have to be a little more careful with the wood, and obviously a lot more careful with the aluminum. So I don't want to say it's like you can just open up Fusion and that day be making complex stuff, but I felt like it was reasonably approachable.
Yeah, sure. I've seen people using these CNC routers to produce a mold for producing composites straight on the likes of MDF, and 3D Magic Mike's one of the Instagram accounts that springs to mind. He's made some amazing parts using that technique. What sort of finish can you get straight off that router? Does that depend on your cutting bits and your tool paths, or is it always going to be some hand finishing required to get to a point where you could actually create a mold in MDF?
Yeah, I mean, it sort of depends on your toolpath, I think, more than anything. If you want to put a 1/2-inch ball nose end mill in there and have it do a step over of 3/1000 of an inch, you're going to get a pretty good surface finish, but it's going to be a 12-hour cut. I think it's probably always worth doing a little bit of, especially if you're doing MDF, you have to seal it anyway.
Plus, it sands pretty easily.
Yeah, it sands super easy. The thing to be worried about, and what I found out with doing the body out of foam, is that the reason that a 4 foot by 3 foot CNC mill that can do aluminum cost $100,000 and mine cost $2,000 has a lot to do with stiffness. Power, obviously being able to like hog out material with the stepper motors and the spindle, but also just like dimensionally being accurate. And the way my router is set up is the spindle hanging off the front sort of twists a little bit in the middle, a little more than it does at the end, because it's more constrained at the end. And it also sags a little bit. So you get your X dimension will be off. So your Y dimension will be off 1 millimeter in the middle, but 0 at the ends. But also it'll be sort of dependent on, let's see, what is it? You get the twist and the sag. So you get your Z will be off in the middle, and your Y will be off in the middle, but not at the ends. And it's just something that it doesn't really matter for me because I'm like making these out of foam, and then I'm hitting, like you take 80 grit sandpaper and you wipe it once across the foam, and you've already knocked out more than that. So, but yeah, if you're doing the stuff that I've been doing where you don't really need plus or minus, you don't need better than 1 millimeter, it's great.
Yeah, application specific and understanding, I think, the limitations of the device is the key here. But I mean, at the same time, no one's going to be using a CNC router to manufacture a billet block. So, billet engine block, it's not going to happen. So probably,
I bet somebody's trying it somewhere.
maybe. Good luck with that 1 millimeter variance. That's probably not going to work out that well for you.
Yeah.
All right, so you've kind of already alluded to it, but obviously the 3 foot by 4 foot bed is pretty limiting when you're making a body for an entire car. How do you get around that?
Yeah, just make it in pieces. So each chunk is. So I just made the engine cover, which is about 15 feet long, about 14 inches high, and about 2 feet wide. Sorry, my mind doesn't work in metric, so I apologize for that.
That's all right. Mine doesn't really work in imperial either, but we'll just assume that these are numbers.
Yeah, it's large. I had to make it in 12 separate pieces, and each one of those pieces was actually stacked together with 3 separate pieces of foam. So I went to the hardware store. Of course, you can buy tooling foam that's made for CNC routers, CNC mills, but it's very expensive. But you can do what I'm doing with just the polystyrene foam you get from the hardware store. So me and a friend went to the store and bought a big stack of this foam. We chopped it up into 2 foot by 4 foot sections, and we glued it together. And then I just went into the CAD model and I chopped up the engine cover into 12 pieces, and then just did tool paths for each one of those. And then we just glued it together. I was originally using dowel pins to hold them, to locate them. But I found out if you just kind of line it up by eyeball, like I said, my tolerances on this are not that close. So
close enough in this case is actually good enough. Also, just worth mentioning there, probably most people, when you sort of use that term polystyrene, they're thinking that the white polystyrene that maybe your TV came out of the box packed in, but it's not that style of polystyrene. I think I used to use it for modeling and making radio controlled aircraft, and that's high density polystyrene. Is that?
Yeah, you can get polystyrene in several different densities, and typically, I actually don't know what the number means, but there's stuff at all the hardware stores carry 250, whatever that means. But you can get it in different densities. But the insulating stuff from the hardware store is noticeably denser than the stuff you get in packaging.
And why that's important, I guess, is when you're then cutting it, sanding it, you're going to get a much better surface finish with that higher density than the traditional sort of white polystyrene, which obviously is important when you're making body components.
Yeah, ideally, I'd get much denser than I have, but it's what's available for low cost. It's again the economy of scale. It's cheaper to get that because a bunch of people are sticking it in buildings when they're building it, and so I can get that for a lot cheaper than I can get the tooling foam.
Definitely. All right, so this kind of leads away from our discussion so far on 3D modeling and 3D printing, etc., and more into composites, which is actually an area that we're producing some courses on, hoping to produce some courses on by the end of this year. We'll see how that ages in time. But composites are another area that I think it's a really valuable skill for home enthusiasts to develop, and it's one of those skills that it takes time to develop, but the cost of the materials is not necessarily huge. Can you tell us how you sort of develop these skills?
Yeah, I did some composites back in college, working on the Formula SAE race car for the wings and the body. And I kind of learned a little bit back then. I tried making a hood for my car back in college, but it didn't turn out that well. And I don't remember exactly why, but I've kind of always hated doing composites. But it's one of those things that you have to do right. You can't half-ass it. You have to do it. You can skip. You kind of just have to spend the money, and you have to spend the time. And it's very messy, and it's very wasteful, and it's the sort of easier you make it, the more expensive it is. I will say that having made a handful of fiberglass and carbon fiber parts for the race car recently, I hate it less. I'm appreciating it more and more. And I think partly that's because I've approached it with a little more, I guess, respect. I don't know, a little more understanding of what it takes to get it done correctly.
Yeah. I mean, I think you hate it less as well when the part comes out of the mold and it looks great. When you've spent a huge amount of time and effort and you pull the part out of the mold and it's just not what you want, then that's super frustrating.
Yeah. I don't think I've gotten to the it looks great part yet. I've gotten to the it's workable and I can make it work if I spend another 3 hours sanding it.
Yeah, nothing a heap of body filler and sanding won't fix.
Yeah, which is what I'm working on right now with the engine cover and the tail.
Well, let's talk about the techniques that you're using to take these foam blocks and actually produce a finished part, because there are a variety of different options, including actually making a mold and then taking the part off the mold, or you're just laying carbon or fiberglass directly on your foam and that's going to be your finished product. Yeah, talk us through how you're using it.
Sure. So with the body, I'm doing kind of several different ways, 5, I think. The engine cover that I was just talking about is actually kind of the way I'm doing it is basically the easiest way to do composites, which is moldless. I think it's the easiest way. Moldless construction, which is I machined this foam mold out of insulating foam, glued it all together, and then I coated that with just this. It's basically saran wrap. It's just a release film, composites release film. Spray adhesive it on. You get some 3M Super 77, spray it on the foam gently. Otherwise, it'll chew away the foam. Stick the release film over the foam, and then you can just lay up your fiberglass. We're using fiberglass, carbon fiber, same way. Just lay it up directly on top of the foam. And this is nice because you kind of know, like I kind of knew, I was doing 4 layers on this, so I knew it was going to be about 95 thousandths of an inch thick. So I just took my CAD model and I just reduced the thickness by 95 thousandths of an inch, machined it out of foam, wrapped it in the plastic, and you do the layup. You put the fiberglass over it, you paint on the resin, kind of work it in there. Do that 4 layers, and then you put peel ply over it, and then you make sure the peel ply is all wetted out. And peel ply is a thing it's used for a lot of different things, but in this case, what it does is it gives you a consistent outer surface finish, and it sort of adds a little bit of a layer of resin outside of the fiberglass, so you can then sand it, and you'll be sanding through the resin and not the fiberglass. This worked pretty great. It worked really well in one of the parts. The larger engine cover, we just used one big sheet of peel ply, and we should have cut it up into smaller sheets because it wrinkled. And so we've got a little bit of wrinkles that I have to sand down in a bunch of areas.
Yeah, it's always difficult when you've got sort of complex shapes with concave or convex surfaces.
Yeah, honestly think it'll be like an afternoon of sanding. I'm going to put on I got it in my backyard under a tarp, and I'm going to put on a bunny suit and a mask and just like dive into the pain of having to sand for a few hours until it's good. And it's fine. Then I'll put a coat of gel coat on it, and it'll be apart. Just today, or yesterday actually, we did a resin transfer vacuum infusion for some flat pieces that I'm making. It's weirdly expensive to buy flat fiberglass. It's cheaper to just make the flat pieces yourself. It gave me some advantages too for adding some reinforcement in there. But we had a piece of acrylic, so I laid that down, and then I put a sheet of release film down, and then we sort of built a perimeter around it with some aluminum with some release film on that. And then we just cut out the pieces of fiberglass and laid them in, and then put a vacuum bag on top, and then pulled a vacuum and then sucked the resin in. We also used a similar method making a parachute tube for the race car. And I really like that. It's way cleaner. It's a lot easier. It's a lot cleaner. And you can usually end up with a part that's, close to what you want without a ton of extra work. The drawback of it is that it's very like trash intensive. It's like the pile of trash that you'll have at the end that you throw away is like 5 times denser than or heavier than your final part. But the next parts we're actually going to do I guess you would call it the more traditional way, where you machine a plug, and then you pull a mold off of the plug, and then you pull your part out of the mold. And that's a great way to get a good surface finish, but that's one of those things where like you have to do it the right way, but you also, now you're making 2 parts and you're prepping 2 different surfaces. And so there's a lot of sanding, there's a lot of mold release, and there's a lot of, ways that it could go wrong. So not super looking forward to that.
I think that the point that's worth mentioning here as well is using the plug, making a mold off that means that within reason, the mold is going to be saved after you've made your part. So if you have to reproduce the part, it's as simple as laying up that mold again, and there you go. Whereas the other technique, where it's a moldless construction, it's a one-off. If you damage that finished part, you're sort of back to the drawing board of making the mold again. So there's a lot more work there.
My foam on the moldless construction actually came out fine. I think I absolutely could definitely, I'd have to maybe recoat them in release film. But I specifically did not want to do the whole thing The only reason I'm doing the plug mold part thing is for the front pieces, which need a really good surface finish, because your aerodynamics, like your boundary layer, by the time you get 3 feet down the car, it's an inch thick anyway. So it's like, it's okay if you don't have a perfect surface finish, but the front needs to be really good. The car's 20 feet long. I don't want 20, 22 feet, something like that. I don't want 20 feet worth of molds sitting around my house, So it's like, maybe I'll have to make this again in the future. I hope not. I'll just remachine a new mold if I do.
Yeah, they do take up a lot of room. I remember we made a carbon fiber. Well, I didn't make it. We had a carbon fiber front clip made for my Evo 3 drag car. So that incorporated everything to basically the front of the doors. And yeah, that mold understandably was huge. It incorporated a sort of a tacked together steel frame to keep it from moving. And, we sort of moved it from one building to another, and it was always a pain in the ass. And in the end, when we moved to Queenstown, where we're based now, I basically gave the thing away. It's like, just, there's not a lot of demand as well for a mold for an Evo 3 front clip out of carbon fiber. It's difficult. So if you don't have a lot of space to store these, I can absolutely understand that. Another technique that I've actually used, and this is sort of back in the model aircraft era, was making the mold, I guess, out of foam, as you've already described, then laying up the carbon or fiberglass on top of that, and then once everything's set up, you can actually melt the foam out of the finished part using something like acetone, petrol. Probably not that environmentally friendly, but I mean, it's a way of getting the job done.
Yeah, the cool thing about having a YouTube channel is I can put up a video and say, like, here's what I'm doing, and I'll get a bunch of comments from people that are like, oh, you should actually do it this other way. Which is a double-edged sword, because it's like, yeah, I've learned something, but half the time I've already finished that part. It's like, this is a thing I would have liked to have known a month ago. But it's always good to know. I really do appreciate those kind of comments. I really appreciate when people have something that they genuinely think is a better idea or an improvement, and they leave a well-worded comment. That's always nice.
Yeah, absolutely. I mean, the flip side of that is I think you also we get a lot of advice that's maybe more questionable in its nature as well, like, or just absolutely like, no, that will not work. That is wrong. I'm sorry, you are wrong.
I find that there is a direct correlation between the quality of the comment and the quality of the information in the comment and the quality of the comment. So like if it's well written and it's polite and it's got like proper, punctuation and grammar, it's usually a pretty good advice. If it's like lots of capital letters and profanity and no punctuation, you can usually just ignore that.
Yeah, you tend to get pretty good at figuring out the comments, just like you said. Otherwise, you sort of drive yourself absolutely crazy. Yeah, I think important, or at least I find, you have to have a pretty thick skin if you want to put yourself out there on YouTube, because some people will definitely want to pull you to pieces.
Yeah, I was really prepared for it when I started. I was like, this is going to be rough, because YouTube used to be the worst place on the internet for comments. And they've done a really good job of, in fact, I think they've actually overcorrected. Whatever they've done to sort of like move the good comments to the top and sort of hide the bad ones has been really good at making it less offensive of a place. But a lot of times it feels like it's almost a little too nice. But yeah, you definitely do need, I think, thick skin, but also I read the comments. I like to read the comments because I want to know if somebody doesn't like my stuff. I want to know if somebody has a complaint. But yeah, that comes with a little bit of a requirement that you can read 10 positive comments and 1 negative one and not ruminate on the negative one for 2 days, Yeah,
100%. I mean, I think in our earlier days, I definitely did get a little bit more upset with some of the negative comments, but you just learn that it is par for the course, and again, don't get too hung up on it. I mean, I think it is important though, like you say, to read the comments and learn if there's a direction that you need to go in to make your videos more enjoyable. Well, you'll definitely hear if you're doing something wrong, and being super stubborn about that. If you're repeatedly getting the similar comments, well, that's probably not too smart if you want your YouTube channel to be successful either.
Yeah, for sure.
All right. Let's move on, and I wanted to sort of talk about some of your project cars here. We'll see how far we can get along with this before we run out of time. But I mean, probably one of the ones that sort of pops up and is something that's just pretty wild, in my opinion, is your off-road Dodge Viper. And I mean, those two terms shouldn't be in the same sentence, or at least in my experience, I wouldn't have thought. Let's start with why.
Well, I think because what you just said, those two terms don't belong in that sentence together. I think it's just a crazy thing. It actually, just looking at it, it kind of like breaks your brain a little bit. I've driven a lot of cars that are kind of like draw attention, and nothing draws attention. Like people who clearly don't care about cars will like stop what they're doing and just stare as I drive by because it's so bizarre. But I think part of that is because the Dodge Viper, it's really the burnouts. I always say the burnouts do not disappoint. The looks do not disappoint. Everything else, pretty disappointing. It's not a good car, but it looks wild, and it's got the horsepower to just light up the rear tires. So it's just like it's like a 12-year-old drew it with a crayon, and then Chrysler just decided to make it. So like, what can you do? Like, what's one step further? If you're already cranked up to 11, how do you go farther? Well, why don't you put a 10-inch lift on it, put some off-road shocks on it, and make it an off-road Viper? It's the why question is tough because it's like it doesn't really make any sense aside from the fact that it's just bananas. It's just crazy.
Let's be honest as well. These projects don't necessarily have to make sense. If they make you smile and you're happy, that's really enough.
Yeah, and it's a fun challenge too. You take something that was never designed to go off-road and you make it go off-road. It's like there's a bunch of little interesting challenges in there to figure out.
All right, well, let's talk about some of the challenges. What were they? What were the biggest hurdles that you had to overcome?
Well, the suspension, obviously, I ripped out all the suspension and completely redid it. It had independent suspension in the rear. I put a solid rear axle in. It's, a lot of popular off-road vehicles still use the solid rear axle. So mounting that, I got a rear axle out of a Jeep Wrangler Rubicon, and it's a 4-link with a Panhard 5-link, whatever you want to call it. So like, obviously this car had no mounting for solid rear axle linkages. So I had to figure out how to mount those in there. So that was kind of where do I want them to be? What gives good geometry? And then how do I get steel to those places to pick that up? And I ended up like going on Turo and like renting a couple of cars. I got a Ford Bronco, a Jeep Wrangler, and the Jeep Gladiator, I think were the three I got. And I had my 4Runner. So I scanned all three of those. I scanned the rear suspension of all three of those. I pulled it into CAD, and I just got the hard points and drew the links and just did a simple kinematic with the Viper CAD. And I was like, all right, what actually works? What's completely unfeasible and what's close? And the Ford Bronco and the Gladiator were both pretty close. And I ended up going with the Bronco because it sort of like, it made the mounting it sort of like put the nodes at places that I could reinforce really well. I also scanned the front suspension on that, and I put that on the Viper CAD, and I was like, okay, I can kind of just steal the Ford Bronco suspension points. I modified it a little bit. I lengthened the upper control arms a little bit, and I messed with the rear links a little bit. But it was nice because like suspension is one of those things. It's like it's so complicated, and every little change will affect everything else. And if you can kind of just steal if you can kind of look over at somebody else's paper and cheat off of them, definitely take that chance. That's kind of what I did.
Yeah, let someone else do all the heavy lifting.
Yeah.
We'll come back one step. Just dive into the independent rear suspension versus a live axle, and what makes the live axle the superior choice for off-roading. Is it sort of articulation that it provides? Fill us in.
So for me, it was a couple of things. It was one, all right, I'm going to have to make this work, I'm going to have to take the rear end to lift it. If you move the tires down to lift the car relative to the chassis, obviously now your half shaft angles are really high. So I'm going to have to drop the differential also to get the half shaft angles reasonable, which sort of now puts my half shafts blowing through the frame. So it's like, all right, well, I'm going to have to cut out this huge chunk of the frame. And then that sort of killed my rear mounting points for the control arms, the upper and lower control arms. So it actually, just by trying to make the geometry work, sort of blew up the idea of carrying over any of the existing rear suspension points or components. So it's like, all right, now I have to redesign an entire new rear suspension anyway. Why don't I do something that I know is a little more proven and something that I can buy pre-made in a package already? Because it's like, okay, with the independent, I have to get, maybe I could have made the differential work, right? But I have to do new half shafts. I have to remount the new differential or the old differential, whatever, in a new place. And I have to make completely new control arms. And maybe I might have been able to reuse the uprights and some of the brake components or whatever. But it's like, it's a significant tear up. Whereas I could just go to Jeep and give them, I forget how much it was. It wasn't very much, for an entire solid rear axle that has an electronic locker, it has the brakes, and it's ready to go from a pretty proven off-road platform. So that was kind of the logic there.
Yeah, that makes a lot of sense. Yeah, okay. And again, really, this is where our discussion of the value of CAD with these sort of projects comes into play. You could already figure out just by scanning and putting into CAD these 3 different vehicles what one was going to give you the least headache. So you don't start with something that's just going to be either absolutely impossible or require 10x the work in order to get it in than the one you chose.
Yeah, 3D scanner, a few hours of scanning and a few hours of CAD did the work of, it just would have been almost impossible to do it without, to do it in real life, to do those analyses. So yeah, it helped out tremendously. You see a lot of off-road, people take sports cars and they'll turn them off-road, but really what they do is they just take the body off and then they put it onto a chassis of an off-road truck, right? And I didn't want to do that. I wanted it to be an off-road Viper. So that sort of requires a lot more integration, I guess, and that sort of requires CAD and 3D scanning and a lot of CAD.
Yeah, absolutely. How effective is it off-road?
I haven't taken it off-road yet. So I just got it running. I think I've driven it on-road probably 5 or 6 times. I think we're going to take it off-road in a couple of weeks. It still needs, so the side exhaust is totally exposed. I want to put side covers on there, although the look of the exposed exhaust is kind of growing on me. And I want a rear bumper. I want to mount the rear tires and the spare tires in the back and a few other things. But I think it's actually ready to go off-road now with a couple other little things. So I think I'm out of town next week, but I think the week after that, we're going to actually take it out to the desert and do some jumps and see if we can break it.
Excellent. Find out what breaks and straight back to the CAD drawing board.
Yeah. It'll definitely need some tuning. There's a big sort of like divot in the road near my house that it's, everybody slows down for it, but you can hit it at 35 miles an hour if you want to. And I did it in the Viper a couple of times and it feels great. So I think it's going to be awesome off-road.
Yeah. Sounds like you're heading in the right direction. Is there any other developments you've got planned? I mean, obviously, once you've taken it off-road, you might see some areas that need work, but is there anything else glaringly obvious that you want to do to it?
So the Viper is a little bit weird. It's not quite a body-on-frame, and it's not quite a space frame. It's sort of like, it looks like a ladder frame from a truck, but with another smaller frame, like 8 inches above it, that's kind of tied into it, and then sort of fiberglass panels stuck to that. I don't know how stiff that's going to be. If I land a jump, is it going to taco? Is it going to fold like a taco? I kind of want to, so the rear shocks, I sort of welded up a node, added some metal to the frame, but there's kind of a really stiff node where the rear shocks mount, and it's sort of just outside of the existing rear roll hoop. And I think it would be cool to weld in a new exterior roll hoop that also goes forward and ties down into the frame that sort of like follows the A-pillar. So it's kind of like an exterior cage for the top of the car that also doubles as a roof rack. I think it would look cool, and I think it would add a ton of stiffness to the car. Because the car is like, you go over a bump and it's a Chrysler quality, right? So it's not really that well made to begin with. But I'm a little worried with as much as it flexes already that I'm going to do some gnarly stuff off-road that's going to like bend it out of whack.
It sounds like the taco is definitely a possibility on that basis.
Yeah.
All right. Well, definitely interested to sort of follow the journey on YouTube once you actually get the thing off-road and see how it does work. Let's move on. And we've already talked a bunch in terms of the bodywork about your Landspeed car. So can you give us a bit of a rundown? What actually is this?
So the original idea was to build a Landspeed car, a streamliner, Landspeed streamliner, which is the fastest of the Landspeed cars. It's fully enclosed body, basically looks like a torpedo. But I wanted to do the smallest engine class. And the smallest engine class for the national records in the United States is 500 cubic centimeters. I decided to go with a 1 liter, to go with a BMW S1000RR and just deactivate 2 of the cylinders. I'm not certain that's the best approach, but that's the approach I took. But I've been sort of running it. Last year, we did sort of shakedown runs to kind of just make sure everything was good. Didn't have a body at all. So my top speed was about 160 miles per hour. And it's like my eyeballs are like 18 inches off the ground. So it's 160 miles an hour feels like I'm going light speed. But also the fact that there's no body on it at all makes it like totally unstable aerodynamically.
I can imagine.
Yeah, it was really tough. You could kind of feel it wanting to just not go straight anymore. And after my third run at Bonneville last year, it kicked out way out to one side, and I pulled the parachutes, and I was like, I think we're going home until I get a body on this and get a vertical stabilizer on the back.
Yeah, I think that's smart.
Yeah. So hopefully this year we'll make it to Bonneville with a full body on it. And I think I'm going to leave the 1 liter. I don't think I'm going to knock it down to 500 cubic centimeters. I think we're going to just leave it at the full 1 liter just to get a good run in, make sure everything's good, change as few variables as possible. I would actually in the future love to. So the FIA, the International Landspeed record, their smallest engine class is actually 250 cubic centimeters. And I would love to get like a supercart 2-cylinder 250cc 2-stroke and see how fast I could go with that. Just because I think it's hilarious to go as fast as possible with the smallest engine. It just seems like a wacky thing that's a really interesting challenge.
Definitely making your life difficult, but I guess with that also comes maybe not as much competition, or is that still pretty hotly contested?
I actually don't know in the international record at 250 what that competition looks like, so I haven't looked into that. Where I'm at now, there's a decent amount of competition, but I think I got a chance just based on my analyses and everything. I think I'm pretty well placed to break the record.
Okay. I need to come back to delve into this deactivation of 2 cylinders on this 1000cc 4-cylinder. And interesting, this is an engine we actually spoke about in depth with Simon Longdill from Prototipo a few episodes ago, and he's used that as the basis of one of his bespoke V8s. So the cylinder head on that engine is just in another realm. So the technology, unbelievable. So it's a great base for building a 1 liter base car. But how do you deactivate 2 cylinders? We're talking here about literally just pull out the pistons and rods from 2 of the cylinders in the valve train and call it good?
So my plan was to just take out the finger followers. So that engine has finger followers between the cams and the valves. It looks like, I haven't checked it, but it looks like at least on I think it's the exhaust valves, you can just take out the finger followers. The actual camshaft won't touch the top of the valve bucket. It might not be true on the intake, so I might actually have to take the camshaft out and grind off the lobes. I did a bit of research into this, and the pumping losses, an internal combustion engine is just a really inefficient air pump. And so the pumping losses are significant. So if you can just deactivate the valves, the friction of the piston moving up and down is, I found there was a paper done by some university where they did like a test on a dyno to figure this out. And I don't remember the exact number, but I want to say it was worth like 2 horsepower or 3 horsepower or something like that. So it's like not zero, but it's not very much.
Not significant.
And that engine, you have to take the pistons out, you have to disassemble a huge amount of the engines. Whereas to deactivate the cylinders is like a little bit of take the valve cover off. And so, plus, of course, if you take the pistons off, you have to take the connecting rods off. And then you're going to have to like put dummy weights where the connecting rods were. Otherwise, the crankshaft's going to be unbalanced. And I don't know what other like secondary or tertiary imbalances you're going to get from not having the pistons moving up and down. So yeah, the plan was to just leave the pistons and connecting rods in there and just deactivate the valves.
Okay. All right. What is the speed that you have to beat to be a record holder?
So the 1 liter class, I believe, is 261 or 262. The 500cc, if I deactivate 2 of the cylinders, is 206, something like that, miles per hour.
Yeah, of course. And did you say 160 you're done with no bodywork on it? Was that correct?
Yes. And I did a CFD using AirShaper on the car with no body, and it correlated pretty well to the amount of power that we had at the dyno and assumed rolling resistances and stuff like that. And then I fine-tuned the body with AirShaper with CFD to get a streamlined body. And so if you kind of take the assumptions we made correlating the no body CFD with a run and put them on the body CFD with a run in terms of like rolling resistance and stuff like that, we're looking at like 290, 280, somewhere around there. So a little bit comfortably faster than 260, especially considering the curve is whatever exponential or.
Yeah. Okay.
But I think that's a little, you never know what the quality of the salt is going to be. You don't know how like the little effects of, I think like seams in the body that don't exactly line up and there's so much weird stuff that goes on between the opening of the tire and the tire, especially when it's so close to the ground. So I wouldn't be surprised if we're significantly slower, or faster than that. But it's different. It's like higher enough that I feel pretty comfortable that we can break the record.
Yeah, I mean, even if you miss by sort of 15 mile an hour, you're still comfortably, or 20 mile an hour, you're still comfortably ahead. So that makes sense. In terms of power, what did it actually produce as a 500cc two-cylinder variant?
We never dynoed it that way. So I think 1 liter we had it at 198 or something.
That's pretty impressive from a 1 liter naturally aspirated engine.
Yeah, I mean, I forget what that motorcycle engine makes just from the factory, but we had it tuned a little bit non-aggressively, obviously, because it's like you're at wide open throttle for an extended period of time. So yeah, I don't know. We'll see.
Okay. Well, it'll be very interesting to see what it does, in fact, do with the body on it. When are you expecting that to actually run?
Hopefully, if we can get the body done, we can do, there's an event at the Salt Flats in, there's one at the beginning of September, late August, somewhere around there, that I think we're not going to make, but there's another one in early October, I believe, around there that we're going to try to get to.
Well, we'll keep our fingers crossed for you. All right, Matt, we'll move towards wrapping this thing up. And of course, we've got the same 3 questions we ask all of our guests. And the first of those is, what's next in the future for you? Any cool projects? Anything else you can share?
I have so many little projects that I really need to wrap up that I think once I finish the Landspeed car, once I get that running and get the Viper wrapped up a little bit, it might just be a several months of finishing up little projects. I do really want to build an airplane at some point. So I think that's in the future at some time. I'm not really sure what that's going to look like in terms of like how much of it's a kit or plans versus whatever, but I don't know. We'll find that out when I get there. Exciting.
That could be a pretty big project. You definitely want to get that right. not a lot of opportunity to pull over on the side of the sky and wait for a tow truck.
Yeah, so I think that's why it's going to be really interesting for me, because my sort of MO, the way I normally do things, is I shoot from the hip a lot. I sort of like don't. Yeah. I lean on my engineering intuition more than I lean on my engineering knowledge. And you can't really do that with an airplane, which is, it's going to be a definite change of just the way I approach projects. So it'll be fun in that respect.
So is aviation already a passion for you, or is this just something you've got on the radar you'd like to move towards?
Not really. I don't know. I've always kind of been a little bit interested, and then I have a friend who bought an airplane, and I hopped in his little 2-seater propeller airplane a couple of times, and every time I fly with him, as soon as I get up in the air, I'm like, oh my God, I need to build one of these. This is so awesome. It's like so cool to just be, you can fly. It's so cool. So, and I think like an airplane from an engineering and fabrication standpoint is like, I always say that like race cars have more in common with airplanes than they do with road cars. And so I think it's not too far away from what I'm doing. The approach on how to build it, I think, is a little bit different, but feels kind of still in the same general area.
Yeah, fair. All right, next question. Is there any advice you'd give to a younger version of yourself to help reach where you are today in your career faster? Maybe potentially avoid some pitfalls that you've seen along the way?
That's a tough one, because I wouldn't have like pictured myself being here. Like my career has taken a few different turns. Like I started out as an internal combustion engineer, and then went to an electric vehicle engineer, and now I'm a YouTuber. You know, it's like pretty different.
Yeah, probably not the normal trajectory.
Yeah, I honestly think that I don't think I would give specific career advice. I think I would probably just give the advice of like, enjoy the path. It's just like, no matter where I would have ended up or where I'm going to end up, it's like getting there or trying to like optimize the destination is probably not the way you need to focus your energy. Probably just enjoy the path there.
Yeah, I think, I mean, I've said this on the podcast numerous times before, but I think if you're doing something that you're passionate about and you enjoy, I think that's probably key. You know, that way, the old saying, if you love what you do, you'll never work a day in your life, which is an outright lie.
Yeah, for sure.
There's still always hard days, no matter what you're doing. But I mean, you know, you're probably going to be ahead of most people in terms of enjoyment in your work. But I think it's ridiculous as well to sort of come out of school at 17 or 18 or whatever age you are and know what you're going to do for the next 50 years or 40 years or whatever it may be. I mean, you know, I barely had a clue when I left school, and I think you kind of have to just roll with the punches a little bit and see what life throws you. And with my trajectory, if I look back, each one thing in isolation, if I look back at my university degree, I really don't use any of that degree in what I'm doing now. And then I ran a performance workshop for 13 years. And that kind of got me the stepping stones to High Performance Academy, but in its own right was kind of almost a wash for 13 years, but I wouldn't be doing what I do now without those intermediate steps. So, sometimes you just sort of got to roll with the punches and see what life brings you, I think.
Yeah, I forget where I read this, but there's an old saying that like the obstacle is the path. It's like, don't try to like move the obstacles out of the way, because that is the path. That's, it's part of the journey.
Embrace it and go with it. All right, Matt, last question for today. If people want to follow you and see what you're up to, how are they best to do so? Give us your social media accounts.
Yeah, it's Superfast Matt on YouTube and Superfast Matt on Instagram. That's pretty much the only places I ever post. So yeah, either one of those.
Pretty easy to remember. Always nice when you can get the same name on two different platforms. And as usual, we'll link to those accounts in the show notes to make it easy for people to find. Well, Matt, great to chat. Really interesting to get your background and backstory, and really cool to hear how you're incorporating technology that is now so accessible and so cost effective into your projects. Hopefully everyone listening can take a lot away from that and hopefully incorporate it in their own projects. Look forward to seeing how you go with that Landspeed car once you hit the salt flats again. Thanks for your time.
Yeah, thank you so much. This was real fun. I'm glad you invited me on.
If you enjoyed this episode of Tuned In with Superfast Matt, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So, this week, a big shout out to Red Bull Guru from the United States, who has said, just constant, incredible content. Amazing long form pods, but surprisingly fantastic short clip episodes as well. The new trend of constant small pods hasn't been enjoyable on a single podcast besides this one. I can't remember a time I've been so happy and entertained while truly learning. Well, thanks for the kind words, and if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview, and before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.